In this video, we are going to explore using algebra to locate potential vertical asymptotes and then using limits to verify if we have asymptotes at those x values. So algebraically, we will have a potential asymptote if the denominator is ever 0. So I'm going to start by setting the denominator equal to 0. And to complete this process, I'm going to factor this binomial here. So x squared is going to factor into x times x. 6 is going to factor into 2 and 3. The 6 is negative, so the larger factor needs to have, one of these needs to be a positive. The 6 is negative, so one of the 2 or the 3 is negative and one is positive. And because there's a positive x, that means the larger factor has to have the plus sign. So I might have an asymptote when x is equal to -5, 2, or -3. So these are the points I need to test. We are going to verify if we have an asymptote or not by using the definition. And so the definition tells us we need to take the limit as x approaches -5, technically from the left and the right, but I'll get there in just a moment. And I'm going to go ahead and use the factored form here just to make things a little bit easier to see. In this exploration, I'm going to start by seeing what happens to each piece. So as x approaches -5, the numerator is going to go to -2. This piece will tend to 0. The x minus 2 will go to -7, and the x plus 3 goes to -2. So it looks like overall, we're looking at a negative number in the numerator and 0, because 0 times -7 times -2 is 0, 0 in the denominator. So this is looking pretty good for us having a vertical asymptote, but we still haven't finished this process. So how could we actually finish this process and show that this limit is positive or negative infinity? Well, we're going to have to do one-sided limits, and this gets a little bit tricky to work out algebraically. So we might just write something out along these lines. So let's take a look at the limit as x approaches -5 from the left. So as x is tending to -5 from the left, what is happening to the term x plus 5? Well, that is tending to 0, but I need to know if this is tending to positive, like tending to 0 from a positive direction or a negative direction. So I might think in my head that a number that is to the left of -5 might be something like -5.01 or -5.001, etc. The x plus 5 is tending to a tiny number, but it will be negative. Okay, so the x plus 5 is less than 0. And so that tells me that my function, g of x, is tending toward a negative number over a tiny number, but a tiny negative number. Okay, because we're tending to 0 from the left. And so overall, as the bottom shrinks to 0 and the top is a constant, division tells us is basically saying how many times does the denominator fit into the numerator. So if the denominator is shrinking, it's going to fit into the numerator more and more times, but the negative signs cancel out. So g of x is tending toward positive infinity. Likewise, as x is approaching -5 from the right, we could say that x plus 5 is tending toward 0. It's shrinking, but this will be a positive number because numbers to the right of -5 are going to be like -4.9, -4.999. And so the x plus 5 will give us a positive number. Therefore, g of x is tending toward a negative number over a tiny positive number. And so we get negative infinity. All in all, this is enough to conclude that yes, there is a vertical asymptote when x equals -5. Let's test x equals 2. So we take the limit as x approaches 2. And again, we'll start with the same idea of looking piecewise what's happening to each part. So the numerator is going to tend to 5. This term tends to 7. The x minus 2 tends to 0. The x plus 3 tends to 5. So it looks like we have a positive numerator, that's a number 5, whereas the denominator is shrinking to 0. So this is looking like we are going to have some sort of asymptotic behavior. But again, we need to explore the one-sided limits to be sure. So similar strategy, I would say, what happens as x approaches 2 from the left? So the term in question here is this x minus 2 term, because that's the piece that's making the whole denominator 0. So as x approaches 2 from the left, these values are going to be like negative, or sorry, these values would be 1.9, 1.999. So x minus 2 will be shrinking to 0. But the question is that positive or negative? And so since the x values are on the left side of 2, they will be slightly smaller than 2. So this negative sign will dominate and we'll be approaching 0 from the left. So it's looking like g of x is tending toward a situation where we have a positive numerator and a negative denominator. So the positive number and a negative number in the bottom means overall g of x is tending towards something that's negative. The fact that the top is constant and the bottom is shrinking to 0 tells us the behavior is infinite. As x approaches 2 from the right, we have enough now to stop and say, yes, we have a vertical asymptote, but let's practice this logic again. As x approaches 2 from the right, x minus 2 is still shrinking to 0, but this time we're shrinking to 0 from the positive direction because numbers to the right of 2 would be larger than 2. And so x minus 2 would be a positive quantity. This tells us then that g of x is going to be in a situation where we have a positive numerator and a positive denominator. But the numerator is a number, the denominator shrinking to 0 gives us the infinite behavior. Either way, we can definitely conclude that when x is equal to 2, we have a vertical asymptote. Okay, last one. What's happening when x is approaching -3? In this case, the numerator is doing something different. The numerator is going to 0. The x plus 5 is tending toward 2. The x minus 2 is tending toward -5, and the x plus 3 is tending toward 0. So here we're looking at something that looks like 0 over 0. So this is a different situation than we had before. Anytime you see 0 over 0, you should think, I don't know what's going on. I need to do more work. So one thing we can say is, let's come back to the limit and look at this structure. Notice that we have an x plus 3 factor on the numerator and the denominator. Now we're taking the limit as x goes to -3. If x is exactly equal to -3, we know that x plus 3 is equal to 0, and we know that division by 0 is bad. However, we are taking a limit. So we are letting x approach -3, but x is not exactly equal to -3. So x plus 3 is tending towards 0, but x plus 3 is not equal to 0. So we aren't dividing by 0 in this limit. Because we're not dividing by 0, it's okay to cancel. And therefore, we can replace this indeterminate limit, this limit where we cannot determine the outcome, with a new limit that doesn't have the x plus 3 term in it. So again, to recap, we can't divide by 0, but we're taking a limit, and the limit is looking at everything but x equals -3. So x plus 3 will not be 0, but it'll be close to 0, but it will never be exactly to 0. So this division is not dividing by 0, so it's okay in the context of a limit. We're replacing this function with a new function that has the same limit, but this is one we can evaluate with substitution. So we just plug and chug, and we end up with 1 over the quantity of 2 times -5, which is a -1/10, which is not infinity. And so we conclude there is no vertical asymptote when x is equal to -3. And what we have going on here, if we were to graph this, is we actually have a hole in this case. So sometimes, if you're looking at a 0 over 0, you might have a hole instead of an asymptote, and you definitely need to explore that by doing these limits.